Okay, so here's an example of the previous one. The reason why I know not to use the arrows going through is I'm not looking for segment CD. If I was looking for segment CD, I would use it. But they're looking for the length of this leg. So anytime I start talking about the two legs of the giant right triangle, I'm going to use the second one. And the way I know to use this one is the x is on this side. So I'm going to go 4 is to x as x is to the whole thing. Leg is to leg as hypotenuse is to hypotenuse. So 4 is to x as x is to 9. So notice the snail look with it. 4 is to x as x is to 9. Or you can even say 4 plus 5 there if that helps you realize you're adding it together. So when I do that, you're going to cross multiply. You're going to get x times x equals 4 times 9. Okay? And then we're going to get x squared is equal to 36. Take the square root of it. We don't worry about the plus or minus because a geometric mean is always what? Positive. So x would equal 6. Now, I'm going to actually change this up just a little bit. What if, okay, what if I want to look for BC? So we're going to change this and find y. Now, all of a sudden, CB over there, BC, is the leg of the larger one. Well, I'm going to use the same process, but it's going to be the snail one. I'm going to go 5 is to y as y is to the whole thing. Okay? So when I do that, it's just 5 is to y. Now what I'm doing is go leg is to leg as hypotenuse is to hypotenuse. So when I cross multiply, I get y times y equals 5 times 9. So y squared equals 45. Take the square root of it. Y is going to equal 3 root 5. So the process can go the other way. Now, on the next one, we're just going to fill these in real quickly of setting up the proportions. This is using similar triangles. This is also setting up what's missing. Now, what they're doing is setting up here using similar triangles. And it's going to be A is to B, so hypotenuse is to hypotenuse, as leg is to leg. So that's really, it's using the small triangle to the big triangle. Uses similar triangles. It's going small to, let's say medium is actually the better way of saying it. So I'm going hypotenuse is to hypotenuse as a smaller leg goes to smaller leg. That's how we're using that one. Now here's the next one. And that says B is to X as, so I'm going to go, where did this come from? I got leg is to leg is really what I'm doing here. This is going to go from medium to the big triangle. Okay? So we're using the similarity. So B is to X, so long leg is to long leg. So this is using the fact that I have the large triangle to the medium triangle is long leg as the hypotenuse of the small triangle to the hypotenuse, the hypotenuse of the large triangle to the hypotenuse of the small triangle. Sorry, trying to get it all in there. So C is to B. The next one, we're going to use our corollary. They go X is to H, and the instant I draw that arrow, it's going to be H is to Y. And that's using first, I'm just going to call it the first corollary. Now let's do the same things over here. A is to C. Now I'm going hypotenuse to hypotenuse, small to small. Okay, A is to C as long leg is to B. So it's to the legs, using similar triangles again. All right, next one. A is to B. Okay, so I'm going to go hypotenuse is to hypotenuse. So small triangle to medium triangle as short leg is to, all right, oops, excuse me, long leg. It'd be A is to B. I got to get these straight myself. Hypotenuse is to hypotenuse as the long leg, which is H, okay, is to the long leg of the medium one. So that would be X. So similar triangles again. Now don't worry, we're not going to spend tons of times on these, but we want to make sure we got this one. Now this one goes A is to C as, now I'm going to change it, this is Y is to A. It really should have been probably written like this. Y is to A as A is to C. That's using our second corollary. But again, these don't matter as much to me. It's just making sure you understand how to set those up. What matters are the proportions. And in fact, we're going to do lots of those on the next page. Here's the first one. Looking at the setup, I'm physically given the length of the altitude of the giant right triangle. So this is when I'm going to use the arrow one. I'm going to go 2 is to 3 as 3 is to x. So 2 is to 3 as 3 is to x. Now remember, the altitudes are geometric means, so it's the one that's repeated, okay? It's the middle one. So you cross multiply, you get 2x equals 3 times 3, which is 9. So 2x equals 9. X is going to equal 9 over 2. Now you will get lots of proportions with these once again. Okay, now notice, let's look at the next one. On B, I'm looking for y and x. The instant you see that and you have the right triangles drawn, think the snail ones, okay? And so remember, I'm going from leg is to leg, okay, as y is to the whole thing. So we're going to go 9 is to y as y is to 12. Basically, leg is to leg as hypotenuse is to hypotenuse. So we cross multiply y times y equals 9 times 12. Y squared equals 108. I take the square root of that. Y is going to end up being 6 root 3. Now let's go the other way. I'm going to go for x. So I'm going to do the same thing, okay? 3 is to x as x is to the whole thing, because I want to go from leg, leg, hypotenuse, hypotenuse. So 3 is to x as x is to 12. Very good. So we get x times x equals 3 times 12. Well, that's x squared equals 36. The square root of that, x is equal to 6. Notice arrows. I'm making it look like the snail shape, right, when we're working with those. It works pretty good. All right, now this one we have a couple different ones we're going to use. Let's look for y first. The moment they bring in that altitude, I always think, all right, connector. 4 is to y as y is to 12. I just automatically connect it up because that altitude is my geometric mean. So I get y times y equals 4 times 12. So y squared equals 48. Take the square root of 48. That reduces down to 4 root 3. Now x, though, is one of the legs of the giant triangle, and so that means I'm going to use the arrows. It's going to look something like that. So I'm going to go 12 is to x as x is to 16. Leg is to leg as hypotenuse is to hypotenuse. I'm using the medium triangle and the large one when I do that. So when I cross multiply again, when I get x times x equals 12 times 16, I think that's 192. And so then we're going to take the square root of that. And by the way, that's 64 and 3. So when you simplify it, x is going to be 8 root 3. Just making sure I can simplify my radicals. All right, now let's do the next one. Like, how in the world are we going to be able to figure out the measures of these? I don't have any parts of the hypotenuse, but actually we do. Actually we do. In fact, we're going to solve for x and y's first when we work with these, all right? Here's the thing I want you to look at. Is this a right triangle? Do I know two of the sides? Yes, I have 3 and a 4. Well, what's the long side going to be? It's going to be 5. It's a 3, 4, 5. So using that, I actually, since I know the whole long side, I'm actually going to use the snail one first. I'm going to go x is to 3 as 3 is to the whole thing, which is 5. So I go x is to 3. 3 is my geometric mean as 3 is to 5. Cross multiply, I get 5x equals 3 times 3, which is 9. 5x equals 9. X equals 9/5. Now I'm going to do the same type of process with z. I'm going to go z is to 4 as 4 is to the whole thing, which is 5. So z is to 4 as 4 is to 5. Kind of cool, right? So 5z equals 4 times 4, which is 16. So really it's 16 over 5. Now those are okay. Yes, I know they're fractions, but don't let that freak you out when you're working with them. But now we have to set up to solve for y. Now y we're going to go like this. Well, I know x and z now. This one over here is 9/5, and this was 16 over 5, so I can set it up. Yes, it's a nastier proportion, but I can easily do it. I can go 9/5 is to y as y is to 16/5. Now, don't worry about the fractions yet, just cross multiply. So I get y times y equals 9/5 times 16/5. So y squared equals 144 over 25. So now we're going to take the square root of that. Remember, you can take the square root of each one individually when you do that process. And what do we get? Square root of 144 is 12. The square root of 25 is 5. So make sure you have every one of those. All right, we're going to practice some more on the other side, so that way we can feel a little more confident with what we're doing.